the work. It's very important that you understand the work.
Yeah.
So today we'll focus on tree diagrams, and then we will work on contingency tables. Okay.
Yes, sir.
So when it comes to tree diagrams, even if you can look at the statement, there is some of the part where we need to be very, very, very smart, okay? And make sure that you read and understand the the diagram, okay?
Yes, sir.
Okay. So now, according to your own understanding, what is a tree diagram? Do you know what is a tree diagram?
Yes, sir.
Okay, so a tree diagram, they are useful for organizing and visualizing the different possible outcomes for a
Yeah.
sequence of events. Okay, so
Yes.
you need to know that for each possible outcome of the first event, we draw a line where we're going to write down the probability of that outcome, and then we're going to state the world and the state of the world if the outcome happened. So you'll see what I'm going to do when I read this question, okay? Right. But before that, let's say maybe we are rolling a die. Can you see my screen?
Yes, sir.
You're going to roll a die. Tell me the possible outcomes of rolling a die. What can we get? The possible outcomes. If I roll a die, what will be the possible outcomes? What will you get when you roll a die? You don't know the possible outcomes.
I do, sir.
When you roll a die, it's either you get 1,
Oh,
2,
six,
3,
four, five.
4,
Oh, okay.
6. You understand?
Yes, sir.
So now you see all of these numbers, these are your outcomes. So when you do a tree diagram, this is how you're going to put it on your tree diagram. You're gonna say, when I roll a die, it's either I get 1, or I get 2, or I get 3, or I get 4, 5, and 6. So this is the possible outcomes. So now you see on these lines, this is where you're going to put your probabilities. So what is the probability that we get 1? So the probability is 1 over total number of outcomes, which there are 6 of them. So it's 1 of 6, 1 over 6. Even for getting 2, that's 1 over 6. Even getting 3, that's 1 over 6. That's 1 over 6. All this will have the same probability. You understand?
Yes, sir.
So this is what we call a tree diagram. Okay.
Yes.
Okay. So now I'm going to read the question, but before we go to a question, there's something that I need you to understand. On a previous lesson, we talked about dependent and independent events. So now tree diagrams are very helpful for analyzing dependent events. Okay, so they will analyze what we call dependent events. And on dependent events, it's where we say the probability of the intersection A and B, it's equal to the probability of A multiplied by the probability of B. This is what we're going to apply in this lesson. You will see as we move. Can we read the statement? Make sure that we understand the statement, then we can start with the lesson. Oh, we
Yes.
already started. Look at all the information that I've explained. We already started. Okay, read the statement.
If it rains on a given day, the probability that it rains the next day is 1 over 3. If it does not rain on a given day, the probability that it rains the next day is 1 out of 6. The probability that it will rain tomorrow is 1 out of 5. What is the probability that it will rain the day after tomorrow? Draw a tree diagram of all the possibilities to determine the answer.
100%. Look at this. You need to first make sure that you understand the statement. If it rains on a given day, the probability it rains the next day is 1/3. So look at this. On a given day, if it rains on a given day, that's today. So this is where we're going to start. Today. You understand? So I
Yes.
think we're going to require space for this one. But let me try to make sure that okay. So we are saying that according to the statement, let's say that we're going to have today, it's either if it rains today, we're going to have the probability that it rains the next day. What are we going to call the next day? Let's call it tomorrow. Okay? Are you following?
Yes, sir.
Okay. So the next day will be tomorrow. Right. So according to the given information, they say that if it rains on a given day, the probability that it rains the next day, so it's either it rain or there will be no rain. So the probability that it rains, it given are, if it rains today, the probability that it rains the next day is going to be 1/3. So listen, tell me, if the probability that it rains tomorrow is 1/3, what is the probability that there will be no rain tomorrow? If it rains today, the probability that it rains tomorrow, it's 1/3. What will be
Yes.
the probability if it rains tomorrow? And what will be the probability that there will be no rain tomorrow? Do you know how to find that one?
Could you explain it, sir?
Okay. The probability of an event happening, when you add them, they must give you 1 in total. I
Yes.
think we did talk about that part, right?
Yes.
Meaning that if we take the probability that it rains tomorrow and the probability that there's no rain tomorrow, when you add them, they must give you 1. So to find the probability of no rain, you need to say 1 minus 1/3. So this will be 1 minus 1/3. That will be the probability. You understand?
Yes, sir.
Right. Therefore, what do you get? What is 1? Do you have your calculator with you?
Yes, sir.
Yeah, because I'm gonna need your help just for us to move fast. What is 1 minus 1/3? What do you get?
Sorry, sir.
What is 1 minus 1/3 on your calculator?
1
What do you get?
minus 1/3 is 2/3.
How is it this 2/3? Did you say 1 minus 1/3?
Yes.
No.
So
Because
I've got
even
2
if I do this without the calculator, look at this. 1 minus 1/3. Okay. So you said you got what?
2/3.
2/3.
Yes.
Okay. Okay. Okay, I think okay, it's fine. Let me just rephrase from what we are doing. We are taking this the wrong way, I see now. We are taking this the wrong way. Look at this. This is wrong. Look, let's go back. Read the statement and make sure that we understand the statement. If it rains on a given day, the probability that it rains the next day is 1/3. If
Yes.
it does not rain on a given day, the probability that it rains the next day is 1/6. So now, the probability that, look at the statement, the probability that it will rain tomorrow, it's 1/5, meaning that for tomorrow, the probability is 1/5. You understand?
Yes, not the 1
Yeah.
over 3.
Yes, it's 1 over 5. Then now, for no rain, what will be the probability? That will be 1 minus 1 over 5. Do you understand?
Yes.
So we were approaching this wrong because we are coming to that 1 over 3. The 1 over 3 is that if it rains today,
Yes.
yeah. So the probability that it will rain tomorrow, it's 1 over 5. So what is 1 minus 1 over 5? What do you get?
4 over 5, sir.
4 over 5. So this is where I'm going to put the 4 over 5. I'm very sorry about that. This is where we put the 4 over 5, 100%. So now listen. Listen. So now we're going to continue with the tree diagram. So on the tree diagram, if we are looking, what is the probability that it will rain the day after tomorrow? So it's either if it rains tomorrow, what will happen the day after tomorrow? It's either the day after tomorrow we're going to have a rain if tomorrow it rains, or the day after tomorrow we're going to have no rain if tomorrow it rains. Are you following?
Yes, sir.
Okay, so it's either we're going to have rain if tomorrow there's no rain, so the day after tomorrow there'll be rain, or it's either if tomorrow there's no rain, the day after tomorrow also there will also be no rain. Do you understand the pattern?
Yes, sir.
Okay, 100%. So now let's fill the probabilities. Let's work on filling the probabilities. So now, listen, this is where we bring that 1 over 3. This is where we bring the 1 over 3. They say that if it rains on a given day, which is this part, right?
Yes.
The probability that it rains the next day is 1 over 3. So this is where we need to write the 1 over 3. If it rains on a given day, we start with rain. The probability that it rain the next day is 1 over 3. Can you see that?
Yes, sir.
So if this is 1 over 3, what will be the probability of no rain? It's 1 minus 1 over 3, which is just 2 over 3. Are you following?
Yes.
Okay. They say that if it does not rain on a given day, and what is that statement saying? If it does not rain on a given day, if it does not rain on a given day, the probability that it rains the next day, if there's no rain, the probability that it rains, that's 1 over 6. You understand?
Yes.
Okay. So now, looking at this information that we have, they say the probability that it will rain tomorrow is 1 over 5. We already have that one on the statement. So if this is 1 over 6, what is the probability that if it does not rain tomorrow, there will be no rain the day after tomorrow? It will be 1 minus 1 over 6, which gives us 5 over 6. I'm not sure if you are following.
Yes, I am.
Okay, so now if you look, let's name this one. This one is the day after tomorrow. Okay, so now let's use this information to answer the question. The question is asking, what is the probability that it will rain the day after tomorrow? Okay,
Yes.
Johan, I need you to move with me. Pay attention on what I'm about to do. Move
Okay.
with me. What is the probability? This is the day after tomorrow. So what is the probability that it will rain the day after tomorrow? There's rain the day after tomorrow here. There's another rain the day after tomorrow here. You understand?
Yes.
Then you're going to draw a line like this. Let's draw maybe a red line. Okay. So you start with rain. We're going to move this line until we get to today. You see?
Yeah.
I move the line like this. Did you see what I did there? I draw the same, and then now you understand the pattern. You understand?
Yeah.
So now, to get the probability of the first situation that it rains tomorrow and the day after tomorrow, we have to multiply the probabilities along the first red line. Do you see the first straight line? This is the part. So we need to find the probability that it rain tomorrow.
Yes.
It rain tomorrow. Where should I write this? And rain after, and rain after the day tomorrow. And let's say, and rain after what? After tomorrow. So we need to first find the probability that it rain tomorrow, which is 1/5. Remember, these are dependent events. We multiply the two probabilities. You take this, you multiply with that. So it will be 1/5 times 1/3. What is your answer? It's just 1/15. Are you with me? Right. Then we are done with the first straight line, which was the one on top. We need to find the other one, which will be the one on bottom. So the one on bottom.
No rain.
Are you you have a question?
No.
Okay. So the one on bottom, it will be the probability that there is no rain tomorrow. There's no rain tomorrow. And there's a rain after tomorrow. Rain day after tomorrow. So we're gonna take this probability, we multiply with that. So this will be 4 over, what is this? 4/5 multiplied by 1/6. I think if we multiply the two, 4 times 1, that's 4, 5 times 6, that's 34, goes into 2 goes into that 2 times into 30, 15 times. And this is the answer. So now, before we move there are some of the mistakes that I don't want you to make. For example, do not take this probability and multiply with that probability because they are not even on the same lane. Please don't do that, okay? Are you still with me?
Yes, sir.
Then to answer the question, what is the probability that it will rain the day after tomorrow? We're going to add the two probabilities. We're going to take this probability, we're going to add it with that probability. And therefore, your answer will be 1/15. You add it with 2/15, which gives us 3/15, which is the same as 1/5. So the probability that it will rain the day after tomorrow is 1/5. And that's it. That's how easy the question is. You just have to make sure that you understand the question. Are you happy about this one?
Yes, it's actually so easy. They just put the words like so high words, confuses it.
Oh, okay, yes. If you struggle with the statement, that's when you're gonna have problems, okay?
Yes.
When we talk about understanding the statement, let's look on, okay, so this one, it was the same example. Talking about understanding the statement, look at this. This one, it's also still part of tree diagrams. So I'm going to take this one slow also because when we say understanding the statement, let's read this question and make sure that we understand what is going on the statement, and we'll try to answer the question. Okay, so the question is saying that, listen, the girls hockey team has a match on Saturday. There is an 85% chance Michaela will play goalie. If she does play goalie, there is a 85%. There is an 85% chance Michaela will play goalie. If she does, there is 70% chance the team will win. But if she doesn't play, there is 45% chance they will win the game. So I guess win depends on if Michaela will play goalie. If Michaela plays goalie, the team has 70% chance of winning. But if she doesn't play, there is 45% chance they will win the game. You understand?
Yes, sir.
So now you're going to separate this thing. First thing first, we have Michaela playing goalie or Michaela not playing goalie. You understand?
Yes.
So I'm going to have, can we call it MG?
Yes.
Like Michaela playing goalie, or the other one will be Michaela
Not goalie.
not playing goalie. And for not playing goalie, you understand?
Yes.
Okay, 100%. Before we go far, let's write the probabilities down. Look at this. There is 85% chance if Michaela is playing goalie. There is a 85% chance Michaela will play goalie. So the probability is 0.85. Don't say 85, divide that by 100, okay?
Okay.
So remember we talked about the probability being 1 in total. So if Michaela playing goalie is 85%, what is Michaela not playing goalie? What is the probability that she will not play goalie?
If she doesn't, there'll be a 45% chance.
No, the 45% chance if it's like if she doesn't, the
yes.
team won't win.
Is it the 70%?
No. Look at this. The first one
Yes.
is 85% chance that Michaela will play goalie. Remember, I said that whatever probability that you write here, when you add it with this one, they should give you what? 1. Exactly. So now, if we already have 85%, this tells you that there is 15% chance that Michaela will not play goalie. So the probability here is 0.15. There is 15% chance. Do you understand?
Yes, sir.
This is the first part of the tree diagram. The first part, you tell us if
Okay,
Michaela,
yes, that makes sense.
yeah, you tell us the probability of Michaela playing goalie or Michaela not playing goalie. You understand? You get it?
Yes, sir.
100%. Then the next part, it's either the team win or they will lose if Michaela is playing goalie. Still, if Michaela is not playing goalie, there's still a probability of winning and there's still a probability of losing. But now they say that if she does play goalie, there's 70% chance the team will win. So if Michaela plays goalie, what is the percentage of winning? 0.7%. You understand?
Yes.
100% you have. I hope you really do understand, right?
I do.
Yeah, so this is 0.7. And then now, if this is 0.7, what should we write here?
Would it be the 0.45?
No, remember the 0.45 is the chance the team will win. But if she doesn't play, there is 45% chance the team will win the game. Yes. I told you that if you add these two numbers, what should you get?
1.
So if we have 0.7, what will be on that part? What should we write here? What should we put here?
So,
remember what we did here?
0.93.
Remember what we did here? We said 1 minus what? 1 minus 0.85, we got 0.15. You do the same. 1 minus 0.7, because when we add these two probabilities, they should give us 1.
0.3 would be, sir.
It's 0.3.
0.3.
Okay, 0.3. Please don't forget that. This will be 0.3.
Yes.
Okay, so this is 0.3. Then we go back to the statement. The statement is saying that if she doesn't play, there is 45% chance they will win. So if Michaela does not play goalie, the percentage of winning is 0.45. It's 45%. And if it's 45%, what is the percentage of losing if Michaela does not play goalie?
So it would be the 1 minus 0.45, which is 0.55.
Thank you. Do you understand how this works?
Yes, I do.
Remember, it's about understanding the statement. So the first
Yes.
probability was telling us the chance that Michaela will play goalie and not playing goalie. Then the next part is win or lose, depending on if Michaela plays goalie or not. If Michaela plays goalie, they say that there is 70% chance the team will win. That's why we said 0.7. So meaning that if Michaela plays goalie, there will be 0.3, which is 30% chance of losing. But if Michaela does not play goalie, there is 45% chance of winning and 0.55% chance of losing. Do you understand?
Yes.
Let's, now that we have the tree diagram, let's attempt answering the following question. What is the probability of Michaela playing goalie and the team win? Look at this. This is how you move. Ne? We're going to look at the first question is looking at the probability. We are looking for the probability that MG for Michaela playing goalie and win. So you will move from Michaela playing goalie, that part, and win.
Yeah.
So you're going to multiply the two probabilities. So the probability will be 0 point, because these are dependent events. On a tree diagram, they are dependent events. They depend if Michaela plays goal or what. The win depends on if Michaela plays goalies or what. So this will be 0.85, which is multiplied by 0.7. And punch that on the calculator. What is the probability equals to?
I've got 119 over 200. Or
What
it's
is that in decimal form?
0.595.
What's the issue with your calculator? Did you say 0.85 times 0.7?
Yes, sir.
Okay, let me just 0.85, we multiply this guy by 0.7. This gives us 0. If you round this to 1%, this is 0.595. You got that?
Yes, sir.
Which is 0.6, right? If we
Yeah.
round it off to one decimal place. So the probability that Michaela plays goalie and the team win is 0.6. Are you happy?
Yeah. Yes, sir.
That was the answer for the first one. So the answer for the second one, what is the probability of the team losing the match on Saturday? You see now, they are changing the question. What is the probability that the team lose a match on Saturday? It doesn't matter if Michaela plays goalie or Michaela does not play goal. We just need the probability of losing. You understand?
Yes, sir.
So you're going to say, okay, this is lose, and then this is lose. Then you move and go back. So this is the branch, and then this will be the branch. So now, when you have two branches, you're going to multiply the branch in the correct order, then you add the two. But I'm definitely, I think I can write that down for you, meaning that we're going to look for the probability that the first part, the first branch, is Michaela playing goalie and lose. And then we're going to take that probability, you add it with the probability that Michaela not playing goalie and the team lose. Then the probability of Michaela playing goalie, let's multiply the first green part, which is 0.85. Multiply that guy by 0.3. Then you're going to add the probability that Michaela does not play goalie, which is 0.15, multiply that guy by that we lose, which is 0.55. So you multiply the two, you get your final answer. So if you do this correctly on your calculator, they should give you 0.34. That's the probability that the team lose on Saturday. So the probability is 0.34.
Okay.
You get it?
Yes.
Okay. If you don't read questions correctly, you're going to have problems, okay?
Yeah.
Okay, and that's it for this question. This was an easy one. Let's move to the next question. This is example 2. Let's see what we have here. Okay, so this one I won't lie. This one is not like really that hard, né? But they say a bag containing this has to do with dependent events. We're going to draw a ball and not replace the ball. So you'll see how this affects the next event. Okay, so we have 3 balls, 4 red metal balls, 5 blue, and 3 green. A ball is chosen at random and not replaced, and then another ball is chosen at random again. Draw a tree diagram to list all the possible events and use the tree diagram to determine the probabilities of the following. Okay, so far we just know that we have 3 balls. The first one is red. The second one is blue. And number 3, that's green. Because it's either we get red, blue, or green. So if the first event was red, this tells you that there is, I'm not sure how I should do this. Let me do this now. How can I do this? Let's do this right. Okay, so if the first one is red, and then we have the second one being blue, and another one green. Okay, let's see if the first one was red. It's either we get red on the second pick. They say we're going to draw a ball is chosen. They say a ball is chosen at random and not replaced, and then we choose another ball. So this is the first and the second event. So it's either we get red, blue, or green. If the first one was a blue, so a red. If the first one was blue, we still get red, blue, and green. You understand?
Yes, sir.
Even the last event, it's either we get red, blue, okay, red, blue, or we get green. So they want us to list the possible outcomes. Né? I'm just gonna use R for red. So for red, this will be R. For blue, let's use blue, B. And then for green, let's use G to write the possible outcomes. So it's either the first outcome will be red and red. So the first one can be red, the second one be red. So the second one can be red, the first one can be red, and the first one can be blue. So tell me, what will be the third possible outcome? Yuhan?
Yes, sir.
What will be the third possible outcome? The first one is like red, then and red. Then
Yeah.
red, then and blue. What will be the third one?
So it's red and green, sir.
Exactly. Red and green. Because I just want to check if you understand what
Yeah.
I'm doing here. Red and green. And then now it's either we start with a blue, then we get a red, or we start with a blue, then we get a blue, or we start with a blue, then we get a green.
Green, yes.
Then for this one is either we start with a green, then we get a red, we start with a green, then we get a blue, or we start with a green, then we get a green. So all these are possible outcomes that they were requesting. Those
Yes.
are your possible outcomes. You understand?
Yes.
Oh, shucks. I don't think the space will be enough for us to write down the probabilities. Ne? Should I rewrite this down here?
You could just continue down there, sir.
Because, you know, I need to write the probabilities on that tree diagrams.
Yes.
Oh, what should I do? Okay. Let me just rewrite. This thing is set. It's either we get red, which will go with red, blue, and green, or ash, you had. Let me do this. Okay, let me just continue, okay?
Yes.
Or it's either we get blue that has red, blue, and green. So I guess the space is still the issue. It's either we get red, blue, and green. Okay, let's just write, we'll find a way to write these things next.
Yes.
I think I can just use this one, the one on top. Okay, so now, what is the probability that we get red? What is the probability that the first pick was red? You're going to count how many red do we have? So there's 4 of them over, the total number of, what is this? The total number of balls inside that bag. So there's 4 red over the total, that's 4 plus 5, that's 9 plus 3, that's 12. There's 4 over 12. So the probability of getting red, it's 4 over 12. So 4 over 12, when you say 4 divided by 12, so 4 divided by 12, what do you get? 0.33, right?
Yes.
0.33. So the probability here is 0.33. Then what is the probability of getting blue? You count how many blue we have. There's 5.
5
so the
over 12.
probability will be 5 over 12. Then you take the 5, you divide by 12. This gives us
0.42.
if you round it off, 0.42.
Yes.
Then what will be the probability of getting green? So for
Green.
green, that will be 3 over 12.
Which is 0.25.
0.25. So this will be 0.25. Then you need to do the same. So for this one, I think you need to pay attention. So I'm just going to move this with I'm going to use a different marker. Please pay attention. For red, remember, we are choosing a ball without replacement. So this tells you that the probability of getting red on the second pick, how many red are left? If we already picked 1, there's 3 left, over how many are inside of the bag. If the first event was red, there's still 11 balls. You understand? They are no longer 12. We no longer have 4 because already the first event we picked red. You understand?
Yes, sir.
So the probability will be 3 over 11. So if it's 3 over 11, this gives us 0.27. So the probability here will be 0.27. Are you following?
Yes.
Then for blue, we still have 5 blue because the first event we picked a red. But we still have 5 out of what? It's no longer 12 because the first event we took 1 ball which was red. So that will be 5 over 11. which gives you what? 0.45. You understand?
Yes.
Okay, 0.45. Then on the next one, the first one was green. They still think green, but there are, how many are they? There are 11. So this will be 3 over 11. You get it?
Yes.
3 divided by 11, that's 0.27. So I'm going to write 0.27 here. Okay, so now let's say that the first event we picked, for the first event, it was blue. This tells you that we no longer have 5 blue. So for the next one to be red, how many red are inside? If the first was blue, there's still 4 of them all over. There's 11 left. So this will be 11 over 4. You see, this is taking time.
Yes.
So this will be 4 over 11, which gives us 0.36. So this one will be 0.36. I'm not sure if you can see my numbers.
I can, sir.
Okay, so let's say the next one is blue. Already the first pick was blue. So there's 4 blue left over 11. So this will be 4 over 11, which gives us 0.36 again. So this one will be 0.36. And then let's say that the peak is green. You see why I wanted space?
Yes.
Okay, and let's say that the peak was green if the first one is blue. So they're still green, but we still have 11. So that's 3 over 11. And this gives us 0.27. Right. We need to do the same for these guys.
Yes.
Okay, so just to save time, I'll say for green, it will be, if the first pick was green, how many green left? There's 2 over 11. So this will be 2 over 11, which is 0.18. And then for blue, the probability of blue, let me write it down, it will be 0.4, 0.45. And the probability of red, let me write it here, it will be 0.36. I hope this does not cause any confusions.
No, it doesn't. That's
You
okay.
sure?
Yes.
Even when the numbers are not exactly where we need to put them.
Yes.
Okay, 100%. So now let's try and answer these questions. Now, then that will be it for this lesson. They want us to find the probability of a blue. I'm just gonna do one and then leave the other one for you to try and attempt them, okay?
No problem.
So I'll do number 1 and then I'll leave this 2 as your homework. You can try and attempt those 2 questions. A blue metal, okay, I think I'll do number 1 and 2. Then we'll leave this one to be your homework.
No
So a
problem.
blue metal ball is first drawn. So we're going to indicate where we have the blue one first. You understand?
Yes.
So blue, we need the probability. We need to find the probability of B for blue and any ball. It can be red, it can be blue. So we need to first indicate where we start with blue. So you know that it will have to do with this part. So all of these probabilities, we need to go with them. You understand?
Yes.
So now, remember, all of them, they start with blue. So we're going to multiply all that side with 0.4. So all these probabilities that you see there on that branch, on this branch, you need to multiply them by 0.42, then add them. So the answer will be 0.42. You multiply with the first probability of getting blue and red, that was 0.36. Therefore, the answer that you get, you add the probability of the second one, because all of those, they start with blue. So it's going to be 0.42. Then you multiply by 0.36. Then you're going to add 0.42. So it's 0.42. You multiply that by 0.27, because this is 27, okay?
Yes.
Yeah, so this will be 0.27. So the answer that you get is the probability of a blue ball mental in the first. Okay, what do
Yeah.
you get when you multiply all these numbers?
0.42.
0.42. So this is 0.42.
No, I'm calculating.
I also got 0.42 on my side.
Okay, I'm saying it out loud while I'm calculating.
I got 0.42 on my side.
Okay.
Okay.
Yes.
All right. So on the second one, they said that find the probability that we get red and then what? Green. Red, then green. What will be the probability? So you're going to look at your possible outcomes. We need the one that starts with red, then green. That's the first one. And then if there's only one that starts with red and green, then you multiply the two probabilities. So it will be 0.33 times 0.27. That will be the probability. So we're going to say this will be 0.33 multiplied by 0.27. So your answer is 0.09. And that's it for this
one. Okay.
Okay. So I'll give you a clue what you need to do on the last one. They say that two metal balls, same color. You're going to look the ones that have same color. So which is green, green, blue, blue, and red, red. You multiply those probabilities, then at the end, you're going to add, meaning you'll start with 0.3 and 0.27. You multiply them. Then you do 0.42 and that 0.3, 0.27. What is that? 0.36. You multiply. Then you're going to add the last one, 0.25 and 0.18. Okay?
Yes, sir.
Do you have any questions based on what we've covered today?
No, sir.
Okay, I'll see you on the next lesson where we will be working on contingency tables or a two-way table. Those are the questions that we'll try and attempt and answer them.
No problem.
Then from there, we can start with the Venn diagrams.
Okay. So could you just send me this note, sir?
Okay, I'll definitely do that. Ne?
Yes. Thank you, sir.